Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials, and my name is Tutor Joseph. In today's video, I'm going to be taking on Chem 112 Chapter 1, a topic called General Principles of Organic Chemistry. Now, Chem 112 is one of the courses that most underlevel students shall be offering as soon as they gain admission. And the code is what 112, and this particular video is going to be based on what chapter 1 of what the textbook. Now the topic is general principles of what organic chemistry. Now organic chemistry is not new to us as science students who have been reading Who Burned the Midnight Oil. Now organic chemistry means the study of the various compounds of carbon except its oxides, carbonates, and what? Carbides. I said organic chemistry means the study of carbon except it what? Oxides, carbonates, and what? Carbides. That is the short introduction to what organic chemistry is. Now, carbon is called what? An ubiquitous what element. That is, it is found everywhere. It is found in both plant and animal. It's what? Ubiquitous. Now, there are certain uniqueness of carbon. We have certain uniqueness of carbon. One, it has a valency. That is greater than 2, but a maximum of what? 4. It has a valency greater than 2, but a maximum of what? 4. The number 2 is large compounds are made up of what? Carbons. Large compounds are made up of what? Carbon. That's why we say it is what? An ubiquitous what? Element. Number 3, it catenates. Catenation is a process where an element forms a straight or branch compound with itself. So it has the ability to what? To catenate. 4, it also has the ability to form with itself single, double, or triple bonds, depending on the organic compound. You know the alkanes they have just a single bond. Then alkenes have double bond. Then alkynes have triple bonds. So it has the ability to bond with itself single, double, or what? Triple bonds. All right, so that is it. Then they have the stability of it have filled shell. All right, the half-filled shell is what? Stable. So these are the uniqueness of what? Carbon. One, it has a valency that is greater than 2, but maximum of what? 4. It does not exceed 4. Now large compounds are made up of what? Carbon, and it is said to be what? An ubiquitous element. It has a bit what? Catenation, processed by it forms a straight or complex or branch compound with itself. It has the ability to bond with itself single, double, or what? Triple bonds. Then it have filled shell is what? Stable. So these are the uniqueness of what? Carbon. Now organic chemistry is divided into two broad categories. Okay. Now we have the aliphatic organic compounds. All right, the aliphatic organic compounds are compounds whose chain are what? Open. They have open chain. Or straight chain. And some of these aliphatic compounds may occur as what? Ring. You call them what? Cyclic aliphatic compounds. All right, aliphatic compounds are compounds whose chain is what? Open or what? Straight. But there are some aliphatic compounds that occur as what? Ring. You call it what? Cyclic aliphatic what? Compounds. Examples are This carbon 1, carbon 2, carbon 3. We call this what? Cyclopropane. Alright, 3 carbon atom, propane. Now, since it's a ring, it's what? Cyclopropane. Now, we also have 1, 2, 3, 4. And this is what? Cyclobutane. And I have 1, 2, 3, 4, 5, 6. This is what? Cyclohexane. I also have something like this. 1, 2, 3, 4, 5, 6. Is that it? This also cyclohexane. So let me draw cyclopentane. 1, 2. How do I? Okay, let us do it like this. 1, 2, 3, 4, 5. This is what? Cyclopentane. You see these ones occurring as rings. They are called what? Cyclic aliphatic what? Compounds. The number 2 is what? This one I've just analyzed is under what? Aliphatic organic what? Compounds. The number 2 is aromatic organic compounds. The aromatic organic compounds are compounds that have benzene ring. No, benzene is what? Ring like. So benzene is like this. That's ring. So this is what? Benzene. Okay, not wet. It's not well drawn. Let me draw it very well. Alright, so this is what? Aromatic compound. Aromatic compound is a compound that possesses what? Benzene ring. Okay, and this one is what? Benzene. Now, when other compounds can also form benzene ring, aromatic compounds. This one, I have OH being attached to it. When OH is attached to a benzene ring, it is called what? A phenol. Right? When OH is attached to a benzene ring, it is called what? A phenol. If I have a methyl group being attached to a benzene ring, it's called what? A toluene. Alright, this is what? Toluene. But if I have double of, is that I have to make it straight. If I have a double methyl group attached to a benzene, that is CH3, CH3. Now I will call it this what? A xylene. This is a xylene. That is when double methyl groups are attached to what? A benzene ring, you call them what? Xylene. Okay. It's good we know compounds that form benzene ring. Now, when CHO is attached to a benzene ring, you call it what? Benzaldehyde. This benz what? Aldehyde. Because of what? The aldehyde functional group. Alright? If this is what? The ketone functional group. And this becomes what? Acetophenone. Acetophenone. Right? Because of what? This ketone functional group, right? If I don't call it ketone, I can also call it what? Acanone. Okay? Now, if I have another one like this, maybe OCH. Okay, let me let me put COOH. and this is what? A benzoic, this is a benzoic what? Acid, okay? So these are different groups of what? Aromatic compounds. If I now have double benzene ring attached together like this, now this is what? Naphthalene. So double benzene ring is called what? A naphthalene. If I now have it to be three like this, three benzene ring, it becomes what? Phenatrine. Three benzene ring is called what? A phenatrine, but two benzene ring is called what? Naphthalene. So these are examples of what? Aromatic compounds. So I believe this one is understood. Benzene ring. Benzene was discovered by a scientist called Kekul. Kekul was the person that discovered what? Benzene ring. Take note of that. So this benzene, phenol, toluene, xylene, and benzaldehyde, acetophenol. Then you now have what? The benzoic acid. So let's take it. The next one is going to be homologous series. Homologous series. What do we know about homologous series? Now, homologous series is not new as well. Homologous series is a family or a group of organic compounds having the following characteristics. Homologous series is a family or a group of what? Organic compounds whose members differ by what? CH2. Each successive member differs with what? CH2. Take note of that. So the following are the features of what? Homologous series. Take note of that. Number one, they have the same molecular formula. Two, they have the same functional group. So these are the features of what? Homologous series. Now three, they undergo similar methods of what? Preparation. They undergo what? They undergo similar methods of what? Preparation. Number four, they undergo similar chemical reaction. So they will ask us, which of these is not a feature of homologous what? Series? Which of these is not a feature of homologous series? Take notes. They'll tell you they undergo this, okay? Okay, let me use, it's the same. They'll say, what A, they have the same molecular formula, which is very, very correct. They have the same functional group, actually correct. They undergo same methods of preparation, absolutely correct. They undergo similar chemical reaction. Now, if you want to confuse, they'll say they undergo the same chemical reaction. So which is not what? Correct. So the answer is what? D. They do not undergo the same chemical what? Reaction. They undergo similar chemical reaction. And of course, I told you that each successive member differs by what? CH2. Each successive member differs by what? CH2. So these are the features of what? Homologous series. Look at the word here. Homologous what? Series. All right. Now, let us look at some homologous series and their various formula. Okay, please, what I'm about to give you now is good. You commit it to memory. The first thing you must take note of when analyzing organic compounds is their molecular what? Formula and their functional group. Number one, I'll give you alkane. Alkane are otherwise called what? Paraffin. The hydrogen formula is CN, H2N plus 1, plus 2, sorry. Then 2, alkene, Alkene is otherwise called what? Olefin. Okay, paraffin is double F. I have Cn H2n plus what? Okay, just H2n. Number 3, alkyne. Alkyne is otherwise called what? Acetylene. Alright. They have chemical formulas CnH2n minus what? 2. Alright, so these are the first 3 groups of what? Homologous what? Series. Single bond, double bond, and what? Triple bonds. Number 4, I have alkanol or alcohols. They have formulas CnH2n plus what? 1OH. Now, this hydroxy group is the functional group of what? The alkanols. Then the triple bonds present here are responsible for what? Their chemical properties. Double bonds, chemical properties. Alkenes have just a sigma bond. They don't have what? Pi bond. Number 5, I'll give you alkanoic or carboxylic what? Acid. And their formula is CnH2n plus 1 COOH. It is this COOH that is what? Their functional group. Now, number 6. Okay, I have aldehyde. Let me give you alkanal. If I don't call it alkanal, I can call it what? Aldehyde. Alkanal or what? Aldehyde. That is chemical formula is CnH2n plus 1 CHO. Alright, this is the functional group. Number 7, I have which one again? That starts with A. Okay, let me give you ester. Okay, let me use alkanoids. Good. Alkanoids or ester. We have CnH2n plus 1 COOR. Now this everything here, if you sum everything together here, you are going to be having what? A methyl group, which is what? CH3. So which means that wherever you see CnH2n plus 1, the same thing as what? Same arrow. It becomes ROCOO, ROCHO, ROCOOH. So that is for that. Now number 8, I have alkanone. Alkanone or what? Ether. Alkanone or what? Ether. Is that correct? Okay. Okay, no. Alkanone or what? Just ketone. Alkanone or what? Ketone. CnH2n plus 1 COCnH2n plus what? 1. So that is for what? For the alkanone. The number 9, that is for the alkozide or ether. Look at it here. Ether, ETHER, not ester. You have it to be CnH2n plus 1 O. This is the functional group of ether or the alkozide. I have CnH2n plus what? 1. So please take notes of the various word formula. Then number 10. Now number 10, which is, let me give you the amine. Amine chemical formula is CnH2n plus 1 NH2. The number 11, if I don't call it amine, I can call it alkanamine, but there's no space. Let me just write it like this. Amide is CnH2n plus 1 CONH what? 2. Number 12, I have nitrile. Nitrile is CnH2 H2N plus 1 CN, that is cyano. Then number 13, I have the acid chloride. The acid chloride is let me bring it this way, please. There's no in that space. There's not enough. Let me bring it this way. I believe all these formulas are entering now. I said number 13 is what? Acid chloride. Acid chloride is also called what? Alkanol chloride. Formula group is what is it called now? Molecular formula is, I'll rub off this one, Cn plus 1 CO Cl2. That is what? The acid chloride. Now you now have number 14. You have acid anhydride. Acid anhydride is Cn2n plus 1. Okay, CO2. Okay, CO squared O. All right, so this is the chemical formula of what? Acid anhydride. And number 15, we have the acyl halide. The acyl halide, I have it to be Cn H2n plus 1 X. Hope it's recording. Good. So this for the acyl halide. So is there another one I've not given us? Is there any other one? So please, I've given you all the homologous series. I gave you 15. So the first thing you do, like I said, is to commit all the various formula to what? Memory. So at this point, I think we'll call it a day. I don't know if I should continue, because the next topic is going to be isolation of what? Purification of what? Organic compounds. That is what? The next topic. Should I take it? Or let me continue. So please, these are the first things you must note: their name and what? Their chemical formula and their functional group. So this is the functional group of these idiots, like I said before. So these are the functional group. All right, take note of that. So let's take the next topic, which is what? Isolation and purification of organic compounds. What do we know about isolation and purification? Now in this topic, we are going to be discussing how various compounds are separated from one another. For example, now if I'm having two immiscible liquids, that is liquids that do not dissolve each other, what kind of technique or what kind of separation technique can I use to separate the both of them? Or if I have an insoluble solid in a solvent, what kind of technique can I use to separate the both of them? Or if I have a coloring substance, what can I use to separate it from other substances? If I have substance that can undergo sublimation, that can change from solid to gas, what kind of technique can I use? So that is what this topic is all about. So isolation, oh god, these markers are bad already. Excuse me. Isolation and purification of organic compound. Now, as scientists or as a future doctor or a nurse or a pharmacist, if you have impurities in a pure substance, what would you do? How would you separate the pure substance from the impure one? How would you separate the the solvent or solute in question, that is the one you have in mind to have as your own substance. You know, they tell in our secondary school days in agricultural science, they tell us that weed are grasses found where they are not what wanted or needed. So in this topic, we are going to be discussing weed and weeds. Weeds is what we want to have, what are useful. The weed is what we are what isolating. We don't need it. We are letting it what go. Now the first isolation or purification method is what extraction. Extraction. Now, in what ways can we carry out extraction? Please, there are two types of extraction. We have solid and solvents extraction. Now, I'm going to be starting with what solvents. Now, another name for solvent is what liquid. Another name for solid is what solutes. It's a combination of solutes or solid and solvents or liquid to form what solution. For example, if I have salt is what solute. I now dissolve it in water called solvent, and we have what a salty solution. That is salty solution. I have sugar, a cube of sugar. I now dissolve it in a liquid called solvent, and we have what a sugary solution. That is it. Now, extraction, that is solid and solvent what extraction. Now, for a solvent to be used to extract another compound, such solvent must have certain characteristics. Now, for a solvent to be used to isolate a compound, please, the rule here is the solvent must be immiscible. That is, the two solvents must be insoluble or immiscible. That is number one rule of what? Solvent extraction. Solvent extraction says that if solvent must be used to extract a compound, the two solvents in question must be insoluble or what? Immiscible on what? Each other. Now, solvents or liquids that do not dissolve each other are separated using what? A separatory funnel. Separatory what? Funnel. Separatory funnel is used to separate two liquids that are immiscible on what? Each other. Example is fuel and water, oil and what? Water. This type of technique is what? Used. Now, solvent extraction says that the two solvents must be what? Immiscible or what? Insoluble. The most commonly used solvent extraction is ether. Ether is used as solvent extraction because of its what? Low boiling point. Take note of this. Number one hint. Ether is one of the most commonly used solvent extraction or solvent that is used to extract compounds because of what? Because of its low boiling point. Because of its what? Low boiling what? Point. And again, you should also take note of the fact that this ether has a low density of 0.34. And again, this ether is chemically inert. It's chemically what? Inert. That is, it does not what? React. Please. Now, ether dissolves most organic compounds. What did I say? Ether dissolves most organic compounds, and it is separated from other organic compounds through distillation. Through what? Distillation. It is separated from other organic compounds through what? Distillation, okay, in steam bath. Now, I said it is used to extract other compounds because of what? Its low boiling points, because of its low density, that is 0.34 gram per dm cube. You now have it is chemically what? Inert, okay. And I said it is okay, good. It is only moderately soluble in water. That is, it is not completely soluble in water. No, it is moderately or sparingly soluble in water. Now, solvent extraction obeys partition theory. Where is Bob that power? God Almighty. Now, this solvent extraction obeys what theory? Partition theory. Solvent extraction obeys what? Partition theory. Solvent extraction obeys partition theory. Now your question meant, or there's a question that will be running through your mind now. What is the meaning of what? Partition theory or partition law? Now, this law states that, let me write it please. This law states that in the distribution of solutes of solute S between two solvents A and B that are immiscible. Look at the word here. They must be immiscible. And are immiscible or insoluble at constant what? Temperature. This law states that in the distribution of solute X between two solvents A and B that are immiscible or insoluble at constant temperature, that if the solutes have, or if the solute is in the same molecular condition, that's if this solute now is in the same molecular condition with the solvents, with the solvent, then the concentration of S in A over the concentration of S in B is equals the solubility of S in A over solubility of S in what? B. Look at it here. Then equals what? Partition what? Constant. Now, I said solvent extraction obeys one law, which is what? The partition law. This law states that in a distribution of solute X between two solvents A and B that are immiscible or insoluble in water at constant what? Temperature, that if the solute now, that is S, is in the same molecular condition with the solvent, then the concentration of S in one of the solvents A over the concentration of S in the other solvent is equal to the solubility of X in A, solubility of S in B equals what? Partition what? Constant. So that is all for that. This is all about what? Solvent extraction. I said ether is used as solvent extraction because of what? Its inert nature, low density, and what? Low boiling point. That is number one, extraction. Number two is what? Centrifugation. Centrifugation is another method of isolating or purifying compounds. That is two. Centrifuge. All right. The separating unit is called what? A centrifuge tube. Now the solvents or the compounds that are to be separated are passed into this centrifuge what? Tube. As soon as the compounds get that is liquid and solid, as soon as they are passed into the centrifuge tube, they are separated based on what? Mass, density, based on mass, density, and shape. Good. Now, which means that the compounds that must be separated through centrifugation must have the following characteristics based on their mass, density, and what? Shape. Which means that the one with higher density will settle on that is at the bottom of what? The centrifuge tube. Which means that the higher the density, the heavier it becomes. That is, it settles at the bottom of what? The centrifuge what? Tube. Which means that the one with lower density will be found suspending on the what? Centrifuge what? Tube. Which means that centrifugation is also a good alternative to what? Filtration. You know, filtration is used to separate insoluble solid from what? Liquid. So please think which of these is a good alternative to what? Filtration procedures. It is what? Centrifugation. A good example is using blood plasma. All right, blood plasma obeys what? Centrifugation. Take note of that. So number 3 is what? Filtration. Filtration is a common way of separating an insoluble solute, yes, from what? A solvent. If I don't use the word solute, I can use what? Solid. Okay. What does it mean to filter? If you are filtering something, it means you are removing the one that is not that cannot dissolve. You are filtering it from it. You know how to cook rice now. So let me go and filter the rice. The rice does not dissolve in water. What you use your filter to remove the rice. You are filtering the rice from what? The liquid. That is what we have here. Now, filtration, I said, is the process of separating an insoluble solute or solid from what? A solvent or liquid. Now, during the process, the solvent is meant to pass through filter paper, comma, gauge fiber, and sintered glass, which means that the filtrating units are actually what? Filter paper, gauge fiber, and what? Sintered glass. Which means as soon as the solvent is passed through all of these, the solvent goes down. Okay, now the solvent that passes through these to the bottom of the container is called what? Filtrate. All right, the solvent that passes through these filtrating units is called what? Filtrate. While the solute or solid found retained in the filter or in any of these is called what? Residue. Take note of that. The one that passes through the filter paper, the gauge fiber, and stained glass is called what? The filtrate. While the one that is found, that is retained in any of these is called what? Residue. So that is for that. Again, please, a basic filtrating method is called what? Filtration. Okay, let me rub on this one. A basic method of filtration is called what? Gravitational filtration. Gravitational filtration. The basic method of filtration is called what? Gravitational filtration, which means that in this type of filtration, gravitational pull is what? Required. Now, this is how it is. Because of the presence of gravitational pull present in a solvent, it will force the solvent through the filtrating units, like I gave us before, filter paper, gauge fiber and what sintered glass. It will push the solvent through the pores of what I've said now downward the bottom of what the container. That is all about gravitational filtration. The difference between normal filtration and gravitational filtration is that gravitational force is required here, but in this very one it is not quite what required. You now also have what vacuum filtration. Vacuum filtration. Now this vacuum filtration, as the name implies, vacuum is a region of space where there is no what matter. It's a type of filtration in which a vacuum is what introduced into the word filtrating unit. Now what does it do? It enhances isolation of large volume of substances. All right, so that is very between what vacuum filtration and normal what filtration. Gravitational filtration, and what vacuum filtration. Please take note of that. Take note of residue and what filtrate. Now another example of separation method is what sublimation. Sublimation is a phenomenon in which a solid molecule passes directly into the gaseous molecule without passing through the intermediate liquid what stage. Sublimation. That is, a solid molecule passes from the solid stage directly to the what gaseous stage without passing through the intermediate liquid stage. What does that mean? It means that, for example, now camphor, quinine, naphthalene, ammonium chloride, that is dry ice, that is carbon 4 oxide, dry ice. Okay, all of these can undergo what sublimation. They can undergo what sublimation. Now, which means that sublimation is used to separate substance that can sublime from substance that cannot what sublime, which means sublimation is used to separate sublimable substances from non-sublimable substances. But vacuolization is used to prevent what sublimation, in the sense that since the vacuum has been introduced, what happens as soon as this camphor vaporizes, it turns to gas, it enters to this vacuum. As soon as it gets the vacuum, it forms what liquid. When that vacuum is opened, it now enters into what the gaseous stage. So which means that vacuolization is another way of preventing what sublimation. So please take note of that. All of these can undergo what? So even benzoic can also undergo what? Sublimation. So another method of separation is distillation. Another method of separation is what? Distillation. Distillation is used to separate two or more liquids that have different boiling points. Look at the word, different boiling points. Distillation is used to separate two or more liquids that have what? Different boiling points. And the liquids are what? Miscible, which means that they obey miscibility and what? Different boiling points. It is used to separate two or more liquids that have different boiling points and they are what? Miscible. Now, this distillation is also used to separate liquid from solid. All right, okay, it's also used to separate solid from liquid rather. However, this liquid must have what? Low boiling point. All right, for distillation to be used to separate solid from liquid, the liquid or the solvent must have what? Low boiling point. How does it happen? Now that you have liquid and solid in the same mixture, what do? You heat. After heating this mixture, what happens? Because of the low boiling point of this liquid, it will vaporize. It will what? Vaporize. As soon as it vaporizes, it is passed into what? A condenser. As soon as you get to the condenser, it cools. Now I recapitulate. Now that you have liquid and solid, because of the low boiling point of what? The solvent, as you are heating a mixture, what happens? The liquid vaporizes and is now passed into what? A condenser after what? Cooling. Now this condenser, which the liquid, which the vapor has what? Retained. What now happens? The distillates or the condensed distillates. It is called distillate because of the solvent that has been taken from it, and condensed distillate because of what? This condenser. Now, which means that this condensed distillate is collected in the receiving flask. Receiving what? Flask. Which means that the integral portion of distillation is called what? The receiving what? Flask. The integral portion of distillation is called what? Receiving flask, and it is what? A container. Please take note of that. So this is the mechanism behind separating solid from liquid through what? Distillation. Now we have different types of distillation. We have different types of what? Distillation. We have different types of distillation. We have one. We have simple distillation. Now, let me explain this quickly. Simple distillation is used to separate two or more liquids whose temperature is below or above 150 degrees Celsius. Simple distillation is a type of distillation that is used to separate two or more liquids with temperature that is above or below 150 degree and differ with 25 degree Celsius, which means that their temperature difference is 25. Their temperature below or above must be 150 degree. Please, which means that which of these distillation is used to separate solvent whose temperature differs by 25 degree? Is what? Simple distillation. Please take note of that. We have another one called what? Vacuum distillation. Now, vacuum distillation has the same meaning with that of what? Simple distillation. The difference is that vacuum distillation is different, and there's introduction of what? Vacuum. It has the same meaning with simple distillation, but the difference is that there's vacuum. Vacuum as what? Introduced into it. Vacuum distillation is used to separate compounds that decompose at high temperature. Hope it's recording. Good, thank God. Now, I said vacuum distillation is used to separate compounds that decompose at high temperature. So please take note of that. So compounds that are prone to decomposition at high temperature are separated through what? Vacuum distillation. Now, number 3 is what? Steam distillation. Now, as the name implies, steam distillation, that is, the steam is passed through what? The mixture that is to be what? Separated. Now, the compounds that must be separated through steam distillation must have the following characteristics. Compounds that must be separated through steam distillation must have the following characteristics. 1, high pressure. Compound must have what? High pressure. 2, high molecular weight. The compound must have high pressure, high molecular weight, then insolubility, solubility or immiscibility with water. That is, the compound must not dissolve in water. The compounds must not dissolve in water. Number 4. The compounds must be soluble or miscible. They must be soluble or miscible with ether. Now, like I said before, I said ether is used as solvent extraction because of its what? Inert nature, low density, and what? Low boiling point. So for steam distillation to be used to separate a given compound, such compound must have the following features: high pressure, low molecular weight, insolubility or immiscibility with water, soluble or miscible with ether. Take note of that. Another method in which we can separate compounds is through fractional crystallization. Fractional crystallization. Alright, it's very easy. Fractional crystallization is used to separate two or more solids with different solubility. Take note of that. With different solubility. Okay? Solubility. Please, I said fractional crystallization is used to separate compounds or solids with different what? Solubilities. Now number 7, we now have fractional distillation. Fractional distillation. Fractional distillation is used to separate two or more miscible liquids whose that have a temperature that is less than what? 25 degrees Celsius. It's used to separate two or more liquids whose temperature is less than 25 degrees Celsius. Please, the integral portion of fractional distillation is called what? Fractional column. And the fractional column connects the fractional disk to flask. That means flask to the condenser. Alright. The integral portion of fractional distillation is called what? Fractional column. And it connects the fractional flask to what? The condenser. Take note of that. Another method that can be used to separate compounds is crystallization, which is what? The last one. Don't say it's difficult. Do you know, no matter how complex a course may be, the only thing that will make such subject to be your subordinate, that will make that subject to be under your feet, is by what? Fervent what? Reading. You read every day, studious mind. As you're even reading, you pray that the Lord help you to assimilate and what? Comprehend. So all of these I've been saying, please endeavor to subscribe, like, share, and comment, and try to understand it. If you are confused in any way, do not relent. Just drop it on what? The comment section. Chem 112 Organic what? Chemistry, Chapter 1. I love organic chemistry. God, good. So the last one for now is going to be what? Crystallization. Crystallization. Okay, no, recrystallization. I don't know the number. Recrystallization. Recrystallization is used in the isolation and purification of impure crystals of its component from its what? Impurities. Recrystallization is used in the isolation and purification of impure crystals of its component from its what? Impurities, which means that for a solvent to be used to dissolve a particular crystal, such solvent must be what? Hot. Hot solvent is used for the dissolution of what? Crystals. Please, solvents that are used during recrystallization must have the following. Solvents that are used during recrystallization must have the following characteristics. One, they must dissolve the crystals when hot. They must dissolve the crystals. Okay, it's one L, please. The crystals when hot and not what? Cold. And not when cold. You can see that the solvent that will dissolve the crystals must be hot. They must dissolve the crystals when what? Hot. And number two, they must dissolve the impurities when hot or cold. So whichever, even when the solvent is hot or cold, it can actually be used to dissolve what? The impurities. I did not say crystals, so the what? Impurities. Now number three feature, these markers are bad already. Now the solvent must not react with the crystal. Right, the solvent must not react with what? The crystal, which means that the nature of the crystal must not be altered. That is, the integral or the integrity of the crystal must not be altered. It must not change. Number four, the solvent must yield sufficient amount of what? Crystals. All right, they must not react with the crystals, and the solvent used must produce a large amount of what? Crystals. So these are the features of the solvents that must be used during what? Recrystallization. My name is Mr. Joseph. At this point, to call it a day. In my next video, I'm going to be discussing chromatographic what? Procedures. How chromatography is used to separate colored substance. We have different types of chromatography. We have paper chromatography, thin layer chromatography, column chromatography. You have a lot of it. So at this point, to call it a day. Thanks for watching, and please endeavor to subscribe. Chem 112 Organic Chemistry. General principles of organic chemistry. Do have a wonderful day.